In this video, I'm going to explain cumulative frequency. Cumulative frequency is a running total of all the frequencies within a frequency distribution. I'm going to be using this example of a frequency distribution, which is the heights of 76 students. And between 130 and 140 centimetres there were 3 students, and between 140 and 150 there were 9 students. These are the actual frequencies. The cumulative frequencies are the running total. So here we have 3 students, then we have another 9, that makes a total of 12, then we have another 26, that makes a total of 38, and then we're going to add 30 to that to make 68, another 6, another 2, etc. So in this video we're going to use a frequency distribution, and with it we're going to calculate the cumulative frequency. We're going to draw the cumulative frequency graph, and we're going to use the graph to find the median and the interquartile range. The easiest thing to do is add another column to this table. So I'm going to add the column and I'm going to call it cumulative frequency. And now I calculate this cumulative frequency by taking the running total. So if I start at this first row, then starting at 130 and up to 140, so by the time I've reached the 140 I have 3, the total is 3. If I consider the next group, then in this row, by the time I get to 150, I'm not really interested in those, but by the time I've got to 150 I've got another 9. That gives me a total of less than 150 is going to be 12. Then in the next row, which takes me up to 160, I've got another 26 students there. So that's a grand total of 12 and 26, which make 38. Carry on to the next row, that takes us up to H being less than 170. There's another 30, so that makes 38 and 30 is 68. And then the next row we've got up to 180, another 6. So that takes us to 74, and then our last row, which takes us all the way to 190, another 2 of them, that makes our 76 students. So this column is the cumulative frequency. Often I'll just call that CF for cumulative frequency. If I'm going to plot this on a graph, these are going to be my X values here, going from 140 all the way up to 190, and then my Y values are going to be the actual cumulative frequencies. I'm starting at 3 and going all the way up till 76. I'm going to plot those as coordinates, so my coordinates are going to be, here's going to be 140 and 3. And this one's going to be 150 and 12. This one's going to be 160 and 38, and so on. So this is the graph paper I'm going to use. Like I said, the horizontal values are going from 140 up until 190. I've done a little bit more than that. And then my cumulative frequencies go from 3 up until 76. So I've started from 0 all the way up until I've gone up to 80. I've even included 100, which I didn't really have to do. Now notice here I haven't started from 0 on my horizontal axes. There are no values between 0 and 130, so it's unnecessary to include it on the graph. What I should do here is put a little jagged line on the axes just to indicate that there's been a break in scale. I'm now going to plot my coordinates. The first one, the upper boundaries, was 140 and the cumulative frequency was 3. Now on this scale, 20 is 10 squares, so each little square is 2, so 43 is halfway there, 140 and 3. My next coordinate is going to be 150 and 12, so with a height up to 150 I had a total of 12 students, so that's just there. My next boundary was 160. By the time I got to 160, the cumulative frequency was 38. 38. I'm going to plot all these points all the way up to 190. Now that these points are plotted, I need to join them up. Cumulative frequency is always a curve. You can't draw straight lines between them. It's a nice gentle transition, so it's a curve. If you go and see the points, you can see it's sort of like an S-shaped curve. The curve's going to come up there, curve around, and then curve this way. I don't ever draw curves by pushing the pencil. That will not give a nice curve. I'm going to get inside the curve, and I draw it with my natural action is my wrist being a pivot. So I get inside the curve and join them up. Where do I start? I could start up here because this is a flat bit. I either start with the flat bits and I can see the curves coming that way, so I could start up there. The other bit is where the curve changes direction. The curve's changing direction here. It's going to come from up there, it's going this way, and then it's changing and going the other way here. So that's a key point there. That's where I'm actually going to draw it from. I'm going to start there because that's where it changes direction a little bit, and then I'm going to get inside the curve and I'm going to actually move the paper. So that's that. Okay. Now I've drawn that part of the curve, I'm going to turn the paper round so I can actually get inside this part of the curve, and I can draw it again with my wrist curving, being used as a pivot, and the pencil curving in the right direction. So now that's going to go around there, little gentle lines to get my bearings. That's it, that's where the curve's going. So I press down and line it in, and that is my cumulative frequency graph. To work out the median and interquartile range, I divide my cumulative frequency into 4 parts, into quarters. Now the highest cumulative frequency is up here, that is 76. So if I take that along here, this is my highest value here, which is 76. It's not 80, you've got to be careful. Some people see 80 on the scale and do that, but that's 76. Now if I do 76 divided by 4, that comes to 19. So every 19 is going to be a quarter, so I'm going to label them up the axes. So 19 is here. So I get my ruler and I draw a horizontal line from 19, take it to the curve, and then I go down to see what the actual value is. And the value is there. I'll do a little arrow so I know which way I'm going. That one there is called Q1. And from the graph I can see Q1 is 153. That's 153. Q1 stands for quartile 1. Now if it's every 19th value you get a quartile, then if I do 2 times 19, that's going to give me 38. So if I look here for 38, that's here. So that's my 38th value. So if I draw my horizontal line now until I get to the curve, it's there, and I take that down, that's going to give me my second quartile. And my second quartile is there. That's called Q2. And that comes to 159. And likewise, if I do 19 times 3, that'll be my third quartile. That's 57. So horizontal line at 57. That's there. And then I go down to get my third quartile, which is 164. That's Q3, which is 164. And obviously my fourth quartile is the maximum, 190. How do these values relate to our median and interquartile range? Well, the median is the middle quartile. It's Q2. The median equals Q2, which equals, in this case, 159 centimeters. interquartile range. The interquartile range is the highest quartile, take away the lowest quartile. So in this case it's going to be Q3 take away Q1. So interquartile range, often abbreviated to IQR, interquartile range, it's equal to Q3 take away Q1. That was the highest quartile, which is 164, take away the lowest quartile, 153, and that comes to 11. So this data, this distribution can be described as having a median, middle value of 159, and an interquartile range of 11. So remember, the interquartile range is a measure of spread. In fact, it's 50%. That's what it is, between two quartiles. 50% of the values are within 11 centimetres of each other. Put that into context, this is height of students, so 50% of the students are within 11 centimetres of each other.